Okay, welcome to volume. We're going to be talking this week about the volume of three specific three-dimensional shapes. Before we get started in on the formulas and how to find the volume of those three-dimensional shapes, we're going to quickly look at what volume's purpose is and what volume is. So to start off, we should define what volume is, and for our purposes in class this week, we are going to define volume as the space inside an object. Specifically for us, it's going to be the space inside of the three-dimensional objects that we are going to be talking about. Now, finding the volume of a shape is important because we use shapes to contain things. We use them to contain food. We use them to define how big a room might be. We use them to contain liquids, both that we might consume or that we might use. So understanding volume is important in a lot of different jobs. It's important in your daily life, and realistically, we see these shapes and those shapes using volume on a daily basis. The three different types of shapes that we will be looking at this week are a rectangular prism, a triangular prism, and a cylinder. Now we found the surface area of all of these shapes before, three-dimensional shapes before, and the formulas that we've used in the past are going to be used again. And what you already know about how to find information on these different shapes is going to prove valuable for you as we move ahead into volume. Before we get into the formulas specific for volume, I think it's important that we review a couple of different terms. When we were looking at the surface area of three-dimensional shapes, those being the rectangular prism, triangular prism, and cylinder, we talked about faces and bases. And when we look at volume, we're going to again be thinking about those different aspects of the three-dimensional shape. Remember that when we look at any shape, we're also looking at that shape's faces and bases. So for example, if we are looking at a triangle, which is a closed shape, and we turn it into a triangular prism, what we're essentially doing is taking that triangle as a two-dimensional form, and we're extending it upwards or outwards in space. So if I want to take this triangle and make it into a triangular prism, I would pull it up from the bottom, or I would extend down. So I would make this into a triangular prism by simply extending it outwards. And we would see this shape form into a triangular prism. When we extend that shape upwards, we are creating faces and bases. The bases of a prism are the congruent shapes. So in a triangular prism, the triangle is the base, and we have three lateral faces. So the three faces on the outside of the prism make up the faces. The triangle makes up the bases. The same is true with a rectangular prism. We would extend it in exactly the same way. And again, as we did with the triangular prism, we would be discovering that there are faces and bases. The bases are the two congruent shapes, and the faces are the ones that extend outward from those bases. Cylinders are exactly the same. We extend the shape and we form faces and bases. In a cylinder, we again have two bases, but in this particular one, we only have one curved face, which wraps around the entire circle. So that curved face goes all the way around this area. So just in review once more, we have a base and lateral faces. Rectangular prism again, a base and lateral faces. And in a cylinder, base and one face, curved face. So once you understand the shapes that we're using and how we extend those into cylinders and prisms, we can start to think a little bit more about the notation that we used in surface area. So to review that really quickly, when we looked at surface area, we were talking about three different types of measurement. We were talking about one dimension, which is length. We talked about two dimensions, which is length and width. And we talked about three dimensions, which is length, width, and height. Remember that when we noted length, we would just use the unit. So for example, if we were talking about this particular line, we would use just centimeters. It is 1 centimeter long. If we were talking about the two-dimensional shape, we would talk about it as centimeters squared. So in this particular shape, we would be looking at 1, 2, 3 centimeters by 1, 2, 3 centimeters. The length and the width. So we would multiply those and we would get 9 centimeters square. The same is true with our last shape, our three-dimensional cube. We would do the exact same thing. We would take our length, our width, and our height, and we would multiply those. So in this square, we have 1, 2, 3 times 1, 2, 3 times 1, 2, 3. That would give us our volume. 3 times 3 is 9. 9 times 3 is 27. So we would now have 27 centimeters cubed. The most important thing to remember when we're noting volume is that we would always use this cubed notation. When we're finding surface area, we would use squared notation. And when we're just finding one dimension, it would just be the unit. So if you have got all this down, we're ready to move into finding the volume of our first shape. And we'll start off with a rectangular prism.